Good morning. Today we are continuing with Unit 10, working with those triangles, and we're learning about something called the Pythagorean Theorem. So we get to learn about a theorem. So this is CO63. I can use the Pythagorean Theorem. So we're going to go through our key terms that we need to know first. First is the right triangle. Who can tell me what a right triangle is? Anthony?
It has like a box.
So it's a triangle that has a box. So if we look at our triangle, what does that box tell us, Anthony? It's a right angle. So it's a triangle that has a right angle in it. So a right triangle has a right angle, and you are correct. It is worth 90 degrees. So that right triangle has a right angle, so we automatically know one of those angles' measurements. The hypotenuse, now this is a new term. So the hypotenuse is the side of the right triangle that is opposite of the right angle. So if our right angle is here, the hypotenuse is directly across from it. So it doesn't matter where that right angle is. Maybe the right angle is up here. That hypotenuse is going to be directly across from our right angle. So it doesn't matter how the right triangle's turned. The hypotenuse will always be across from the right angle. The legs are the two sides of a right triangle that form the right angle. So we know this is the hypotenuse, these two are the legs. So this is the hypotenuse, these two are the legs. So the legs are the ones that connect the right angle with the hypotenuse. That makes sense? So we already knew right triangle, now we know hypotenuse and we know legs. So Gabby and Will, everything good back there? Because I'm not seeing eyes paying attention. So our key concept is the Pythagorean Theorem. For any right triangle, the sum, what does sum mean?
Addition.
Addition, we're adding. The sum of the squares of the lengths A and B of the legs, so we would call this A and this B, equals the square of the length C, the hypotenuse. So it looks like this. If we're squaring it, it would be A squared, so that's one leg, plus B squared, that's another leg, equals the square of the hypotenuse, C squared. A squared plus B squared equals C squared. It's math, and this is like big kid math. Yes, A squared plus B squared equals C squared. This is like real math, like big stuff that you will use in high school. You need to know it. Yeah, we're getting into real math here, friends. Yeah, I see those eyes getting wide, Peyton. This is important to know. Zoe. We use it geometry. This is part of geometry, and we use it in when you're doing measurements of stuff. So I can't give you an example off the top of my head right now. I will think about it. Okay. So let's look at how we're going to use A squared plus B squared equals C squared. So to find C, we're going to use the Pythagorean Theorem. Let's make a triangle that has that right angle. A is going to be 15 and B is going to be 20. So remember, A and B are our legs. So if A is 15, B is 20. And we want to know C, the hypotenuse. How do I set up my equation. Yeah.
15 squared plus 20 squared.
So we have 15 squared plus 20 squared equals c squared. So we're going to need calculators. Remember, if you don't have a calculator from home, you need to get one. So 15 squared is 225 plus 20 squared is 400 equals c squared. So now I have 225 plus 400 is 625 equals c squared. Is that my answer?
No, you have to figure out what c squared is. Like,
Oh,
625.
it's not c by itself. It's c squared. And we need to simplify it all the way down to just c. So if I look at c squared, remember we're doing opposite operations. What's the opposite of squaring, Mia?
Dividing.
Not dividing. The square root.
Oh, yeah.
So I need to find the square root of 625, and the square root of c squared would be just c. So what is the square root of 625? What is the square root of 625, Tristan? 25. Just 25. So on your calculator, if you do your square root symbol and then do 625 and hit equal, you will see what the square root is. Because if we do 25 times 25, we get 625. So we're finding that square root because we want c just by itself. We had to do the square root of c squared would be just c. c times c is c squared. So we want to bring it down to that square root. How do we feel about that?
Good.
Yeah, it's doing the equations that we've been doing. We just need the biggest thing to remember is this is c squared. So you need to do the square root. So don't forget about the squares. A squared plus b squared, remember to square them. And then remember that it's c squared, so you need the square root, multi-steps. So some of us like to put it just all into our calculator. When we see this equation, don't forget to show your work. Show what it is that you're doing. So if you make a mistake, you know where you went wrong. Or if you got the answer correct, you know what you did to get the correct answer. Let me move the paper up so we can see the next section. Maybe if it'll erase. There we go. Approximating the length of a hypotenuse. For a right triangle with A is 8 millimeters and B is 8 millimeters, find the length of the hypotenuse to the nearest tenth of a millimeter. So if we have 8 millimeters and 8 millimeters, here is my right, because it's a leg and a leg, going to that right angle. So I want to find C. So how do I set my equation up? Will W?
8 squared plus 8 squared equals c squared.
8 squared plus 8 squared equals c squared. So 8 squared is 64 plus 8 squared is 64 equals c squared. 64 plus 64 is 128 equals c squared. So now I need to find the square root
Oh, this one's
of 128. So
Yeah, it's two numbers.
why would it be 64? Because we added, weren't multiplying. It wasn't 64 times 64. We added them together. So no, if we had multiplied 64 times 64, the square root of it would be 64. But we were adding them here. So the square root of 128 gives us decimals.
Oh, it does?
It does.
Yeah.
We need to find to the nearest tenth. So Peyton, did you find the square root of 128?
Well, it says in my calculator, so it's like 8 outside of the square root like box, and then like 2's inside of it. It makes no sense.
So when you
Bring your calculator over.
yeah, I know how to fix that.
Okay, bring it to Tristan. It's just one button that you have to click.
No. Is
Isn't
like
it?
I have to
Or-
click- oh, I just clicked.
You had to click two?
Yeah.
Okay,
Oh, I just clicked.
so you got it?
Yeah.
Anthony?
Oh, is it 11.3?
Yes.
Yeah.
So
A lot.
the directions told us to round it because 128 isn't a perfect square. Okay, remember perfect squares are my favorite kinds of numbers. 128 is not one of my favorite kind of numbers. So that's why we have the decimals. That's why it says approximating the length, because it's not going to be just a whole number. Does that make sense? If you get a square root that isn't a perfect square and you get the decimals, just go to that nearest tenth. Finding the length of a leg. All right, so we are setting up a tent. The ropes used to hold the tent down are 5 feet long. So let's pretend this is our tent. Here, let me use different colors so we can see it. Here's my tent. I have a rope holding the tent down here, and that's 5 feet long. Wait, let me see what their tent, oh, their tent was a square tent. That's how the difference is. So their tent looks kind of like a house. And they have a rope holding the tent down. That rope is 5 feet long. We have the ground. So we can see where that tent hits the ground is our right angle. So we know the rope is 5 feet long, and each rope attaches to the tent 3 feet above the ground. So it's 3 feet up, it's 5 feet long. How far from the base of the tent should each rope be staked down? So we know a squared plus b squared equals c squared. Which of those letters let's look at it this way. Which of our two lines are the legs, and which one is the hypotenuse?
Okay.
Josie?
So the 3 and like the ground are the legs.
3 in the ground, because the ground is what we're looking for. 3 in the ground are the legs. Because here is our right angle, so directly across from it is our hypotenuse. I'll write it out. So the hypotenuse is directly across from our right angle. So our hypotenuse, we know, is C. So our legs are A and B. So if you label your triangle, you can see what your missing variable is. So we have leg A, we know it. Leg B, we do not know it. That's our question mark. C, the hypotenuse, we know it. So now we can go to our formula and fill in the numbers that we know. So what is it going to look like? Mia?
3 times 3 squared plus
Do we know B? No, so we're going to put it as our variable, B squared, because we don't know that one. equals what?
Equals C squared.
Do we know what C is?
Equals
5
5.
squared. Don't forget your squares. So what I'm going to do first is I'm going to find out my squares. 3 squared is 9 plus b squared. 5 squared is 25. What's my next step going to be? Bria?
I did I know what
Why am I going to subtract my 9, which was 3 squared? Why am I going to subtract 9 from 25? Yeah, we want b by itself. So we want to do our opposite operations. We want to move that 9 over to the other side of the equal sign. 9 minus 9 is 0, so we don't have to write that. So I have b squared. 25 minus 9 is 16. Oh, so is my ground 16 feet long?
No, you have to do square root.
But b equals 16. Oh. I love the excitement, Anthony. Why isn't it b equals 16?
You have to like kind of move it.
Oh, because it's not b, it's b squared.
Okay,
I need to find my square root of both of them. The square root of b squared is b. What is the square root of 16, Will? 4.
Yes.
Because 16 is a perfect square. So the square root of it is 4. So here's the important thing to know when you're given information like this. Write it out. Figure out what are your 2 legs. What is your hypotenuse? So you can see, do I know my A and B and I'm solving for C? Or do I know that hypotenuse and I'm solving for one of the legs? It makes your steps different. So be very careful when you're filling in your information that you're putting them in the right spot. You can't assume that you're always getting the A and the B and you're solving for C. Sometimes you have to solve for the A or the B. Any questions on using the Pythagorean theorem? Okay, we are going to be working on pages, is it 133, 130, no, 147, 148. Pages in your workbook, page 147, 148. To my friends at home, we hope you are well and we hope to see you soon.